In this lesson, you're having this nice integral. Okay, we are going to use integration by part. Where's our u? U is equals to what? 1 plus x squared under the square root. Therefore, du is equals to what? You have half. I just integrate, differentiate here. That is 1 plus x squared to the power half. Okay, half. Into what we differentiate the inch here. That is 2x. And we keep it 1 plus x squared all to the power half minus 1. This and this will cancel. And you are left with what? Just erase x all over square root of 1 plus x squared. And our dv is equals to 2n x to the power n to the power 2n plus 1. Therefore, our v is equals to x to the power 2n plus 1 plus 1 plus 2 all over 2n plus 2 using the power rule. The question you're asking is why are we taking u and dv this way? Okay, because looking at this, it's more easier to differentiate 1 plus x squared, square root of that, than to integrate it. Because if you have to integrate this, you're going to have an extremely long method. I'll just stop it here on how to integrate 1 plus x squared, the square root of that. Okay, then integrating this is quite easy, short step. Okay, having this, then substituting the initial equation using minus integral of v du. We're going to be having what? What's our u? And this, okay. 1 plus x squared, 1 plus x squared, square root of that, times x to the power 2n plus 2 all over 2n plus 2, 2n plus 2. With limit from 0 to 1. I just substitute this one is and have the answer directly. If you put 1, that is 1, 1, or 2. 1 here, that is 1 to the dot, that is 2, 2n plus 2. Okay, that is what you're going to be having. If you put 0, 0 will cancel, will be 0 everywhere. Okay, that is minus integral from 0 to 1. We just v du x to the 2n plus 2 all over 2n plus 2 times v du x over square root of 1 plus x squared dx is what we're going to be having. Okay, and this numerator can simplify further to be having what? If you combine these two, you are going to have x to the 2n plus 2 plus 1. For me, this is x to the 2n plus 3. Okay, proceeding. You have root 2 over 2n plus 2 minus integral of from 0 to 1 of x to the 2n plus 3 all over 2n plus 2 times square root of 1 plus x squared dx here. Okay, we can just limit at this point. Say you have to integrate for the second time in order to have a I to the n minus 1, because 2n plus 3 is not equivalent to I to the n minus 1. Let's try 2n plus 3. You substitute I to the n minus 1 here, you're going to have 2n minus 2 plus 1. And that will be equal to 2n minus 1. This is not equivalent. We're going to integrate this for the second time. Okay, hence we are going to do this in our next video. I will show up here. Another way of integrating this, in case we have to integrate and take, we just see what's what x to the 2n plus 1. Okay, taking this as normal, du is equal to 2n plus 1 x to the 2n plus 1. And our dv is equals to, we take 1 plus x squared under square root. We have to integrate 1 plus x squared under the square root. Integrating this, we are going to have with x all over 2 square root of 1 plus x squared plus half ln of square root of 1 plus x squared plus x. Okay, to integrate this, I'm going to drop the video up here on how to integrate this one. Okay, substituting this in the equation, we are going to have what? X to the 2n plus 1 dot x all over 2 square root of 1 plus x squared with limit from 0 to 1. We can directly substitute the values here. So if it's 1, we're going to have 1, 1. That is what? 1 here, you have 1. That is root 2 all over 2. In case it's 0, we're going to have 0 minus half integral from 0 to 1 of what? X all over 2, we just recopy. That is uv minus integral of v du, or v is this x squared, x on 2 square root of 1 plus x squared, x on 2 square root of 1 plus x squared times 2n plus 1 x to the 2n dx.